Hello, this is 7.6, Properties of the Equilibrium Constant. So today's objective is to be able to represent a multi-step process with an overall equilibrium expression using the constituent K expressions for each individual reaction. So you can find the K or Q value for an overall reaction if you know the value for K or Q of each step. It's kind of like Hess's law a little bit from last unit, but the rules are a little bit different because we're dealing with quotients. So let's see, we have just kind of a general example. We have an original reaction of A plus 2B produces C, and let's say that the K1, the constant is, excuse me, let's say it's 100. So to get the expression like we did last time, K equals concentration of C over A times B squared. So if we flip the reaction, you're taking the inverse of the K1. So the inverse of 100 is 0.01. So then you would flip the K expression. It would be A times B squared over C. Assuming we keep the same order as the original reaction, but we multiply by a factor, let's say 2, notice what happens to the K1. It becomes squared, and our the parts that make up the K expression, they become squared as well. So originally it was concentration of C over concentration of B times B squared, but then by multiplying the reaction by 2, you have to square everything else. If you combine two reactions, then you multiply their K values. So we can see from the first example, that, so what are they doing? We are just adding them together because our C's cancel out. So we're left with A plus 2B plus D produces 2E. So our K1 times K2 makes our overall K for the reaction, and that will be 500. And as you can see, your K expression at the end is basically, it's the overall reaction itself. So you can see that the C's disappear, and then you have E squared over A times B squared times D. So change the color of my pencil. Given the following reactions, calculate the value for the K for the overall reaction. So looks like what we got. We have A plus B produces C plus 2D. The K1 is going to be 5. D plus B produces E with the K2 of 15. So let's look at how they end up combining it, at the end. We end up with A plus 3B. Oops, excuse me. Sorry, A plus 3B produces C plus 2E. And what is the overall K? That's what we're trying to find here. So I'm going to rewrite this down here just to make it a little more, so I can do the work, I guess, so to speak. So we have A plus B produces C plus 2D. We got D plus B produces E. Let's see, how can we end up with A plus 3B produces C plus 2E? Well, I kind of want to keep this one, the first one, in that order, because actually I want to keep these all in the same order so I can kind of just end up with the A's and the B's on the reactant side still. However, I want to get rid of the D's. So notice how the D's are gone in my final reaction right here. So what I'm going to do with this bottom one, I'm going to multiply all of it by 2. And I'm going to rewrite this. So what ends up happening is that it becomes AD, so 2D plus 2B produces 2E. Then my 2D's cancel out. And in the end, I actually end up with A plus 3B produces C plus 2E. So like we said, if we multiply a reaction by a factor, we have to do that same type of factor to the K. So let's see, K1 equals 5. K2 is actually squared because I multiplied everything by 2. So this becomes 15 squared, which is, hold on a second, 225. So my overall K is K1 times K2 squared. So it's going to be 5 times 225. So just the value is 1,125. Okay, very good. Let's look at the next slide. Give you all a second to look at it and see what we can do. So we have our K value. So let's just say this is K. Oops, wrong ink. Try green. K1, K2, K3, and I'm sorry, and I wrote it wrong. So silly. So K1, K2, K3. Very good. Calculate the value of K for this reaction. We have x 2 minus aqueous plus H plus makes HX 1 minus. HXCl produces, it looks like it decomposes to HX minus plus Cl1 minus. Then water is hydrolyzing into hydrogen and hydroxide ions, back and forth, of course. So it looks like we got a couple of things we need to do for this. Let's just say we got our work cut out. So in the end, I want to keep, it looks like I want to keep this in this second one in its same place. But with the water here, the OH, I'm sorry, on the reactant side, I need to flip this. And according to looking at the first one, I want this on the product side. So I got a lot of flipping to do with this one. So I'm making it, I'm going to do this. So I'm going to flip the first one. Oops. Oh my gosh. Oh my gosh. Sorry. That means that I'm taking the inverse of my K value. So this is going to be, I'm going to run out of space. My K value will be to the -1. So I'm going to put this up here so you can see it. This can be K1 will be to the -1. Okay, so my second one, I want to keep it the way it is. You can kind of see what the plan is. Oops. All right, so I'll keep K2 the way it is. My last one, I want to flip so I can get the hydroxide ions on the reactant side. Sorry, I don't know if you can hear my PS5 in the background. Hashtag not sponsored by them. So H2O liquid. So I flipped my K3. So this one will also be to K3 will be to the -1. So let's see. Let's make sure that my things cancel out, and I end up with looks like I don't have any coefficients with these, so they should just cancel out. So my HCl is where I need it to be. My OH1 minus is where I need it to be. My X2 is on the product side. My Cl1 minus is on my product side, and my water is on my product side over here. So that means that my HX's canceled out, and as well as my hydrogen ions. Very good. So keep that in mind. I'm going to, guess I'll write on the bottom here. How do I get my K value? So K equals the invert, well, I'm multiplying all of these, so multiplying by the inverse of the K1, 1 minus, times K2 normally. Then also my K3 will be inversed as well. Let's see what I end up with. Okay, very good. So on my calculator, I'm just going to show you I'm going to write out what I typed. So it's going to be 5.8 e negative 4 to the negative 1 times 6.2 e9 times, 1 e negative 14 to the negative 1. I end up with sig figs in mind, based on what I am working with, I'm going to end up with 1.1 times 10 to the 27. Okay, so looking at this, at equilibrium, are the products or reactants favored? Just remember that according to our last topic, if my K value, if it's really, really small, less than 0.001, reactants are favored, barely anything happens. If it's less than 1, reactants favored. Greater than 1, products favored. If it's really, really bigger than 1, which this one clearly is, its reactions going to completions, which is what's not really being addressed right now, but what is being favored. Because of the really high K value, your products are going to be highly favored. Use this one. Okay, so if you have any questions, please let me know. Thanks.